Hi everyone, welcome to the Getting Started with OPM series on objects and processes. My name is Joy and I'm the founder of Optimize Academy. In this introduction video, we're going to briefly introduce what OPM is and we'll go through what you'll learn in this course. So for those of you who may not be familiar with OPM, OPM is a methodology for modeling and engineering complex and multidisciplinary systems. It can be anything like an aircraft or even a natural system like the atmosphere. OPM was first developed in 1995 by Professor Dov Dori from Technion in Israel and is now recognized by INCOSE as one of the 6 leading MBSE methodologies. It is also standardized into its own ISO specification and has been widely used by organizations like Airbus, NASA, and MIT. Now, many of us may have come across diagrams like this, where in first glance looks very reasonable and understandable. But as you look deeper and deeper into the diagram, you may wonder, what does an ellipse mean and what does a rectangle mean and why are there arrows in all different places? In contrast to this kind of casual diagrams, OPM as a formal modeling language has a mathematically grounded definition of syntax, and this provides a very robust framework for us to build models for our system. This framework is built on a minimal universal ontology that consists of only 2 elements, entities and links. Ontology in this context is like a set of alphabet, which allows us to compose descriptive and long passages. By having such a minimal yet expressive ontology, OPM allows us to model even the most complex systems without losing any fidelity and details and still maintain the simplicity of it so that it is easily comprehensible for all of the different stakeholders, regardless of whether they are engineers or not. Now, another very useful feature of OPM is that it expresses model facts using 2 modalities, graphical and textual modes. This means that for anything that you've put into an OPM model, a corresponding sentence called the OPL, Object Process Language, will be generated that reflects your model fact. And these OPL are always generated according to a set of defined rules so that the sentences are deterministic, consistent, and always the same for the same kind of model fact. So this means that even for non-engineers stakeholders, as long as they can understand English or any other languages supported by OPM, they will be able to understand your model and therefore your system simply by reading your model like a living documentation. And you can feed it to other machines or even Gen AI tools, and they will be able to understand your model in a more systematic and structured way. Now, OPM treats a system as something that has a purpose, and its architecture is the combination of its structure and also its behavior. This system is designed in such a way so that the purpose can be achieved. In contrast to other object-oriented paradigms, OPM treats both objects and processes as first-class citizens. This means that processes are standalone elements that can exist independent of the objects or the systems. Some of you may have heard of SysML, which is another popular system modeling language. While SysML provides different diagram types to model the different aspects of a system, in OPM we simply stick to the same kind of diagram and we decompose the system simply using different levels of abstraction. This allows the modeler and also the reader to understand the system without having to switch across different contexts, and you'll be able to understand the model just using the same minimal universal ontology and the same kind of diagram. So now that you've got an idea of what OPM is, if you're interested in learning more about object process methodology, feel free to check out the bonus lecture in this course or search Getting Started with OPM on Udemy to see our full series of courses on object process methodology. Now, in this introductory free course, we're going to learn everything about objects and processes, which are the building blocks of OPM. And feel free to access OpCloud Sandbox through this link so you can practice creating OPM models side by side with me along in this course. Now, in the first lesson, we're going to look into objects and states, and then in the second lesson, we're going to learn about processes. Finally, in the last lesson of this course, we're going to look into some of the properties of things, which are objects and processes in OPM, that allows us to express model facts in a more concise and accurate way. In between all of these lessons, there will be quizzes that are designed to consolidate your learning, so feel free to try them out as well. And finally, to complete this course, we'll have a scenario quiz on coffee making, which is a very common example used in system modeling. In this scenario quiz, you'll be presented with an actual OPM model, and you'll be asked to answer some questions according to this model. We also highly recommend that you try and replicate this model in the sandbox, so you'll be familiar with how to actually create a system model based on what you've learned in this course. So I hope you enjoy the quizzes and the course. Without further ado, let's get started. Now, earlier we talked about OPM's minimal ontology that consists only of two elements, entities and links. Links will be something we talk about in another course. For this course, we'll focus on entities instead. Now, if you are new to the concept of system modeling, it might be helpful to think of a system as a story. You always have a particular message that you want to convey, and your story might serve a special purpose as well. Imagine you are a systems engineer trying to model your system and present it to your chief engineer or even to your clients as well. Now, you might want to explain to them what's the purpose of this system and how its inner functions and its interactions with the external world help achieve this purpose. In this case, in OPM's context, entities form the substance of your story, and on the other hand, links form the storyline. This might be a little bit too abstract to comprehend, so let's take a look at an example from our daily lives. Let's imagine you're driving a car. What are some objects or processes that you can think of? Let's take 5 seconds and do a quick brainstorming. You can even pause the video and jot down your notes. Okay, so for me, I can definitely think of the car, which is a physical object, and actually passengers as well, they are also regarded as objects in OPM. You might think that it's quite rude to say a passenger is an object, but you'll see later on throughout this chapter why we've made this simplification in OpCloud and consider passengers and actually speed and fuel efficiency, which are intangible concepts as well as objects. Then for processes, I can also think of driving, which is a process that involves changing the passenger from origin to a destination. And stopping as well, which is also a process that brings the car from being in motion to static. And even transmitting data. Data transmission is something that we can't see or hear, but it does happen. So it's also considered a process in OPM. Now, you might also think that this is an oversimplification because we are categorizing everything when it comes to driving a car to either objects or processes. How do we distinguish between living things like passengers or non-living things like the car, or even tangible or intangible things? In OPM, as you'll see later on in lesson 3, there are actually some mechanisms that allow us to distinguish all of these things. With these mechanisms, we don't need special categories like living objects or non-living objects or tangible objects or intangible concepts, and OPM can remain as concise and simple as it is right now. Now let's take a look at some formal definitions for entities. In OPM, objects and processes are collectively known as things. And on the right-hand side, we have an OPM diagram that explains all of these relationships. These notations might look a little bit foreign to you right now, but don't worry, as I'll explain along the way. And hopefully by then, you'll also see how simply information can be presented using OPM, even though the information itself could be quite complex. Also, throughout this course, I've capitalized all of these terms like objects, processes, and things. This is just to remind you that all of these terms have special meanings in OPM, and they are not just everyday phrases. Now, the formal definition of an object is that objects are things that exist, and for processes, processes are things that transforms objects. You can see that these two arguments are quite circular, but it's actually a requirement that allows OPM to be self-sustained. By using OPM to explain what OPM is, we've removed the dependency of any other external theories to support it. Now, in addition to that, objects can also be stateful. States in this case is like a situation or a scenario or a condition of the object, as you can see on the diagram here. State is a situation of object, and object can be at state. To give you some examples, the car from before can be broken or operational. Broken and operational are the states of the car. And the repairing process can change the car from being broken to operational. As you can see on the diagram as well, process changes state. So this is one way it can transform an object. As mentioned in the definition, processes are things that transform objects. And together, things including objects and processes and also states as well are collectively known as entities in OPM. And just in these few slides, you've already grasped half of OPM's minimal ontology, because as we said earlier, OPM's minimal ontology consists only of entities and links. Isn't that amazing? I hope you appreciate how simple OPM is, and despite how simple it is, it's still very, very expressive that allows us to model even the most complex ideas. Throughout this course, we'll be using OpCloud quite a lot with all of the examples and exercises, and you're also encouraged to replicate the models shown on the slide or do it with me during the demonstrations as well. Let's familiarize ourselves with how OpCloud works. Now, OpCloud is a web-based tool that stores all of the data and model on the cloud, so you don't need to install anything. You only need to access this link, opcloud.systems, and log in with your credentials or use the sandbox. OpCloud is developed by the same team that's developed OPM, so you can be rest assured that OpCloud implements all of the features and even more capabilities of OPM as well. If you have been given a professional license that allows you to access OpCloud, you can use it to create as many models as you like or experiment all of the latest features as well. Okay, now let's take a look at OpCloud. This is what OpCloud's user interface looks like. In the middle, you have a canvas area where you can create your OPM models. And each of the model facts you've created in this canvas area will generate a corresponding OPL sentence at the bottom. You can also hover over each sentence and see the highlighted part in the diagram that corresponds to this particular sentence. Then at the top, we have a top menu bar. This menu bar is contextual, meaning that it would change based on what you've selected. For example, if I've selected an object, you can see a list of different options have shown up. And if I've selected a process, other different options will also show up. And there's also another contextual menu when you click on either the objects or the process. This three-dot menu here provides some other usual options that allows you to quickly access them as well. Then on the left-hand side, we've got the OPD tree. This OPD tree here lists all of the diagrams you have in your particular model. Right now, we only have the system diagram, SD, that's why there's only SD in here. However, as you build your model more and create more diagrams, you'll see that OpCloud lays out all of your diagrams in a hierarchical manner. Now, below that is the draggable OPM things, which holds all of the objects or processes that you've created in this particular model. And you can drag them into your canvas in order to reuse that particular object or process as well. And at the top, you can see here we've got all of the tabs for the different models that you've opened up. OpCloud does autosave your model from time to time. However, it's still a good idea to regularly save it manually in order to avoid any data loss. To do that, we can go to the top left menu bar here and click Save or Save As, so you can save your model. Once you've done that, you can load your model using this option here. You can also export your model, for example, exporting the OPL as a document or just the diagrams, the OPD, into different picture formats. You can also export both the OPL and the OPDs into a PDF or as an HTML. However, note that you can't export the model as an OpCloud file because that doesn't exist. So this means that your model cannot be transferred outside of the optimized organization that you're part of right now. And you can also import model if you've used OpCat before, which is their legacy tool. And something worth mentioning as well is the load example option here. You can load up some global examples, which are their official examples created by OpCloud, or you can also load up organizational examples, which are the examples I've created as part of this course. And you will see a lot of different examples from the slides as well. So you can open them up at the same time along with a video, or even do it side by side with me as well. So this is what OpCloud looks like, and I hope you try out all of the new features and feel free to experiment with it and create as many models as you like. So enjoy!